Okay, today we're going to talk about the counting principle, 12.1. Um, Now this continues on with some of our probability talk that we talked about the other day. First thing we're going to talk about is independent versus dependent. Now I'm sure most of us know what those two words mean, but let's write them down anyways. Independent, what does that mean? Well, independent means it's going to occur without influence. Or in other words, it's going whatever we're talking about, if it's an independent event, it's going to happen no matter what. It doesn't need something else to happen. Versus dependent needs something else to occur. Okay? So like for many of you, if you want to go to prom or to a dance, something like that, that's dependent upon someone actually driving you there because many of you can't drive. So dependent needs something to occur. Independent can do it on its own. So the big topic today, though, is this thing called the counting principle. Now this is a pretty wordy definition, but we're going to see if we can simplify it. It says, if event M can occur M ways and is followed by independent event N that can occur in N ways, the event M followed by N can occur M times N ways. And this is, out of all that, this is the most important thing. So, what does that mean? Well, what it means is if you have, as it says here, independent events, okay, and you have multiple ways that those things can occur, if you want to figure out the total amount of ways that those things can occur, you multiply the possibilities. Now this is something that you probably already know how to do. And again, my definition probably wasn't the greatest, but let's do a couple of examples and you'll understand. So it says, with a deck of 52 cards, how many combinations are there? Or 3 card combinations are there? Well, if we're going to be picking 3 cards, and I want to know how many different ways I could pick 3 cards. Well, essentially you have 3 spots. You have the first card you're going to pick. Well, out of 52 cards, how many choices do you have? Well, you have 52 choices right there. Now, if you've done that, and now you're going to pick the second card, how many choices do you have? Well, you only have 51 choices because you've already picked one card here. And then thirdly, if you're going to pick the last one, since you've already picked 2 cards, there are 50 there. So to figure out the total possibilities, you multiply those 3 things together. And if I multiply 52 times 51 times 50, I end up with a really big number. Okay, so I get 132,600 different 3-card combinations you could have. Not terribly difficult. And believe it or not, that's what this whole complicated definition was trying to tell you. Now, what if I put a couple restrictions in there? Let's say I tell you if the first card is 10, how many 4-card combinations are there? All right, let's see. So we're dealing with 4, and you don't have to draw these blanks, but I like to. The first card is 4. Well, how many 10s are there in a deck of cards? Well, there's 4 of them. Okay, then from there, we're just picking any old cards. So once I've already picked one card here, now it happens to be a 10. How many cards could I possibly choose? Well, 51 left. And the next one would be 50. The next one would be 49. Again, multiply all those out. 4 times 51 times 50 times 49. And we end up with almost 500,000 different choices. Oops, that's an 8. Okay, so again, not terribly difficult. You're just trying to figure out how many different possibilities you have to choose in each one of those spots. So that last one. Let's say I told you that the first and third cards are red and the second card is black. Okay. First, black face card. Sorry, I forgot about that one. So you got to know a little bit about cards here. So in a deck of 52 cards, okay, half of them are red and half of them are black. So in this choice, or in this example, it says the first card is red. So that means I have 26 choices right there. And then from there, this one is telling me that the third card is red also. So since I've already picked one here, then here it needs to be 25. And lastly, it says the second card is a black face card. Well, face cards are kings, queens, and jacks. Okay, sometimes people think ace is a face card, but it's not because it doesn't have a face on it. But all three of these have faces on it. Now, how many face cards are there in a deck? Well, there's 3 per suit, and there's 4 suits, so there's 12 face cards. But we're looking for a black face card, so it's half of those, so there's 6. So 26 times 6 times 25, 3,900. Okay? And that's basically it. That's it. Doesn't get much more complicated. I mean, we can do some more complicated examples, but we'll end up doing that when we get closer or when we get into class. But that's the general idea, and hopefully that makes sense. So, as always, if you have questions, make sure you bring them to class. Thank you.